Hi everyone, my name is G. Sandhya Kumari, Assistant Professor from the Department of ECE, SysTech, Puttur. So today I am going to learn about the relationship between the Fourier transform and Laplace transform from signal systems and random process. So if you're going into the topic, these are the course objectives of signals and systems, and these are the course outcomes of signals and systems. And Laplace transform. The Laplace transform, it converts a signal from time domain to S domain. So it is useful for solving differential equations. So Laplace transform in time domain as L of x of t equals to x of s, where integration is integration minus infinity to infinity x of t into e power minus st dt. Here s is the complex variable S equals to sigma plus j omega, where L is a Laplace transform that converts a time domain function into frequency domain. The conditions for existence of Laplace transform are the x of t should be continuous in a given closed interval, and it exists only less than infinity. The Laplace transform exists for signals for which the Fourier transform doesn't exist. It's one of the advantages of Laplace transform. Advantages of Laplace transform. Signals which are not convergent in Fourier transform are convergent in Laplace transform. The convolution in time domain can be obtained by multiplication in S domain. The LTI system can be easily analyzed using Laplace transform. And the limitations of Laplace transform are the frequency response cannot be estimated, but pole zero can be drawn. S equals to j omega only for sinusoidal steady state analysis. Next one, relation between Laplace transform and Fourier transform of a signal. The Fourier transform is represented as x of omega equals to integral minus infinity infinity x of t into e power minus j omega t dt, where from the inverse Fourier transform, x of t equals to 1 by 2 pi integral minus infinity to infinity x of omega into e power j omega t d omega. In the place of omega, just replace sigma plus j omega, where from that x of sigma plus j omega equals to integral minus infinity to infinity x of t into e power minus sigma plus j omega t dt. Similarly, we can apply the same replacement in time domain function of a signal. And then the next step is by replacing s in the place of sigma plus j omega in the above equations, we can obtain x of s equals to integral minus infinity to infinity x of t into e power minus st dt. And similar way, the time domain function x of t equals to 1 by 2 pi j integral sigma minus j infinity to sigma plus j infinity x of s into e power st ds. The Laplace transform is nothing but complex Fourier transform. And this is a tabular column that represents the Laplace transforms of elementary functions. And these are the references. And these are the web references. Thank you.